Hello everyone, I am Anjali Brahmane, Faculty of Civil Engineering Department from Vishwavarti Academy's College of Engineering, Ahilyanagar. Here I am representing online lecture series for fluid mechanics subject. Today's topic is fluid dynamics. Now, first we will see the content. The introduction of fluid dynamics, the forces acting on fluid mass in motion, the Euler's equation of motion along a streamline and its integration, assumptions of Bernoulli's equation, modified Bernoulli's equation, and its application and limitations. Next, linear momentum equation and kinetic energy correction factors. Momentum correction factors. And last one is venturimeter, orifice, and orifice meter, rotameter. Now, first, will we see the definition of fluid dynamics? The study of forces which produces motion in a fluid and based on the fundamental principle of Newton's second law of motion. The net forces equal to mass into acceleration. Next, the forces acting on fluid. There are five forces. First, gravity force. Second, pressure force. Third, viscous force. Fourth, turbulent force. And last one, compressibility forces. Therefore, net forces equal to Fg plus Fp plus Fe plus Ft plus Fc. Now first, gravity forces. Gravity forces, it is due to weight of the fluid. Next, pressure forces. Pressure forces, the pressure gradient between 2 points in the direction of flow. It is pressure forces. The third, the viscous forces. Viscous forces, it is due to viscous properties of the flowing fluids. Fourth, the turbulent force. It is due to turbulence of the flow. And last is compressibility forces. The compressibility forces, it is due to elastic property of fluid. Next, the Reynolds equation. Reynolds equation. If compressibility effect is neglected, the net forces is equal to gravity forces plus pressure forces plus viscous force plus turbulent force. It is Reynolds equation. Next, the Navier-Stokes equation. If compressibility and turbulence effect is neglected, and the net forces is gravity force plus pressure force plus viscous force. It is Navier-Stokes equation. The last is Euler's equation. If the flow is considered as an ideal flow, it is net force is equal to gravity force plus pressure force. The Euler's equation. Next, the Euler's equation. Next is assumptions of Euler's equation. There are three assumptions. First is only pressures and gravity forces are dominant and all other forces are negligible. The second assumption is flow is steady. And third is the flow is ideal and non-viscous. Next is Bernoulli's theorem. It states that in a steady ideal flow of an incompressible fluid, the total energy at any point of the fluid is always constant. Therefore, the total energy is equal to constant. The mathematical expression is 1/2 rho v square plus rho GH plus rho equal to constant. Next, assumptions of Bernoulli's equation. There are 7 assumptions. First is the fluid is ideal. The flow is steady and continuous. The third is the flow is incompressible. And the flow is one-dimensional. Fifth assumption is velocity is uniform over the cross-section and is equal to the mean velocity. Sixth assumption is the gravity force and pressure force are only considered. Last one is the flow is irrotational. Next, practical application. First, venturimeter, orific meter. Third, submerged orific. Fourth, pilot tube. And fifth is V-notch. Next slide is limitation of Bernoulli's equation. The first limitation is it is applicable to ideal incompressible force flow. Next, the heat transfer into or out of fluid should be zero. The temperature remains constant so that internal energy does not change. And last limitation is uh, the effect of pressures of any mechanical device between two sections is ignored. Next, modify Bernoulli's equation. All particle fluids are viscous. So, there is some losses in fluid flow between two sections. The Bernoulli's equation is modified by considered losses. The mathematical expression. Next, impulse momentum principle or linear momentum equation. This principle is based on the law of conservation of momentum, which states the net force acting on a fluid mass is equal to the change in momentum of flow per unit time in that direction. Next, practical application. The first is flow through vane pipes. Second, jet propulsion and propellers. Third, fluid flow through stationary and moving plate or vanes. Fourth is non-uniform flow through sudden enlarged pipes. Fifth is hydraulic jam in open channels. Next, energy correction factors. There are two types of energy correction factor. First is kinetic energy correction factors, and second is momentum energy correction factors. The flow measuring device, the variable head types and variable area types. Variable head types, venturimeter, orific, nozzle, and variable area types is rotameter. First, venturimeter. The definition of venturimeter is it is device used to measure the speed and flow rate or discharge of fluid through a pipe. Next, venturimeter is work on Bernoulli's equations. The third, the principle of venturimeter is firstly developed by G.B. Venturel in 1797, but this principle comes into consideration with the help of C. Herschel in 1887. The main part of venturimeter is converging cone, throat, and diverging cone. Now see in figure, converging cone, throat, and diverging cone. First is converging cone. It is starting section of venturimeter attached at inlet pipe, and the cross-sectional area of this cone start to decrease and the converging angle is 20 degree. Its length is 2.7. Here, D is the diameter of inlet section and small d is the diameter of throat. Other end of converging is attached with throat. Second, throat. The throat is middle portion of venturimeter and its cross-sectional area is too small. The pressure is decreases and the velocity is increases. One end is connected with converging part and the other end is attached with the diverging part of throat. The diameter of throat is 1/4 to 3rd foot of the diameter of the inlet pipe, but mostly it is 1/2 of the diameter of the pipe. The third, diverging cone. The diverging part is end part of the venturimeter and its cross-sectional area is increases continually. The angle of diverging part is 5 to 15 degree and its cross-sectional area continuously increases. Next, the one end is connected to throat and the other end is connected to outlet pipe. The main reason of behind the low diverging angle is to avoid the formation of the because flow separation and eddies formation will result in large amount of loss in energy. Thank you.